All right, everyone, this is Mr. Wyrick, and I'm going to guide you through the 3.4 dilation notes. This should be for Monday the 13th. You can't see the calendar, but we're supposed to spend 2 days on this. We're going to kind of condense it down to one. So there's going to be some delta math for you to do, and we're going to look at some stuff about that. Okay, so I'm going to go step through step on these slides to make sure that you guys can see exactly what's going on with these, and we'll work from there. So step number one is just the thing that says dilation notes. Right now it says notes for 127 because I guess that was what it was last year, so I'll change that to 213. Slide number two, what is dilation and how is it used? When we talked before about similar shapes being the exact same shape but a different size, we make the rectangles bigger, we make the triangles smaller, whatever it is that we're doing, that is dilation. We are taking those similar shapes and recreating them. They keep the same angles, the sizes are the same ratio relative to one another, it's just different sizes. And in dilation, we are, instead of just looking at ones that has happened, we are creating those. If you are zooming in and out on your map or on a picture, if you are playing a 3D video game, that's dilation. It's still on a 2D screen. So slide number three, the types of dilation. If we have a point on an object, now this is shown here, we have triangle ABC, and then we have triangle ABC, and we have B prime and C prime. My center of dilation for this one is on point A. So point A stays exactly where it is, and everything else increases its distance from point A, and the relative distance of the others would stay the same. So our scale factor on this one is going to be somewhere around 2. It's tough to tell if you don't have an actual grid. If you're not dealing with this on a set of coordinates, it's kind of tough to tell. Okay. Slide number four, the next one, next type of dilation is from a point that is not on the shape, but maybe within the shape. You can see we have triangle ABC and it has point O in the middle of it, and they're using that point O as the center of dilation. So this gets bigger and all of them travel out in a straight line from where O connected to it. So if you were to connect O to B on this, you could draw that exact same straight line through and end up at B prime. If you were to connect O to A, you could draw a straight line through and end up at A prime. So these are the things you kind of need to put into the notes. The types of dilation, we get bigger or smaller based on a point on the object for that slide number three. We get bigger or smaller based on a point that's maybe inside of the shape, therefore number two. And then the third type, we can dilate the image by making it smaller, okay? We go like half the distance down to that point O. But the big one is going to be this slide number 6. Whenever you dilate on the coordinate plane, you're going to take the coordinates of each point that you have and multiply by the scale factor. So this is where it gets kind of easy and where it also gets kind of hard. If we have A at 4,3 and the scale factor is supposed to be 2, we're going to go from the origin. So if we're doubling that distance of 4,3, it's going to be 2 times 4 is 8 and 2 times 3 is 6. You have to multiply both the x and the y by that scale factor. This can also be difficult if you're thinking, oh, it's half the distance, so I'm just going to divide them. Technically, no, it's always multiplying, so you're going to multiply by 1/2 rather than divide by 2. So our sample problems that we have here on the 7th slide, it says we have points at J, K, L, and M. We are dilating from the origin, and our scale factor is 2.5. Okay, well, 2.5 times -2 is going to be -5, and 2.5 times 4 is going to be 10. So instead of -2, 4, it's going to be -5, 10. So it'd be back 5, up 10. You have to make sure to apply this to both the x and y values, or, excuse me, it doesn't really work. Okay. You can have some difficulties if we would have had any odd numbers there. Multiplying by 2.5 would be some difficulty. If we look at the second one, we have A, B, C, and D. We're using the origin, and our scale factor is 1/2. So right off the bat, A is 3/4. Half of 3 is going to be 1.5. Half of 4 is going to be 2. So we go over 1.5 and up 2, and that's going to give us our spot. Okay, so make sure to take these down. Your assignment for today, and I'll go ahead and type this in on the notes, is going to be in Delta Math. Now, this should be the last day that I miss for this week. We have another tennis meet on Friday, but there's no school on Friday, and we're off for President's Day on Monday. So that's some things there to look forward to. On the Delta Math, I do want to kind of show you one. So I'm looking at it here on the computer. And if I can aim this, it says we're dilating by a scale factor of 2 with a center on the origin. And it wants us to click twice to plot a segment. But really, I'm just thinking in terms of individual points. So this is F, and it's at 0, 3. So 0, 6 would be double that. Here's G, and it's at -1, 3. So I multiply the -1 by 2, that's -2. I multiply the 3 by 2, that's 6. So there I have my new, that would be F prime, G prime up there at the top. Okay, so very important. Make sure you're going point by point, putting those where they are supposed to be. And then once you have them all connected, you should be able to put that in there. And I believe this, I think the dilation on the coordinate plane is going to be the only one that I really work with. I won't worry too much about anything else. So that'll get us a good spot to go from. Now, going back to the calendar, we have that dilation. When I come back, we'll do the 3.5, defining congruence and similarity through transformation, talking about how to translate shapes onto one another, that kind of stuff. And then we'll have a practice performance task, a review, and we'll have a test that's based on this information. So we've got a busy week coming up. Make sure you're staying up with stuff. Make sure you're not getting behind. Right now, it's Super Bowl Sunday. I'm going to be updating those major grades, those test grades, kind of getting everything done there. So hopefully your grade kind of improves. If you're still missing stuff, make sure you're getting it taken care of. Have a good one, and we'll see you when I come back.